Now, the second half of our statistics unit comes out of chapter 10 in your textbook. It's on bivariate analysis. Now, that is when you're looking at two variables, like bicycle has two wheels, bivariate has two variables. We're looking at relationships between those variables. Okay? So here is an example of a scatter diagram or a scatter plot. It shows a relationship. Okay? Right? If I add a dot to this, what does that mean? What would that dot that I just added mean? Say, so in that one's, yeah, it might be an outlier, but specifically, that would mean there's a married couple. The wife is really old. She's 80, right? The husband is 30. Okay? Right? We could also have that as an outlier over there. 80-year-old man, 30-year-old wife. Which of those two happens more often in our society? The younger wife and the older man? Okay. And what's usually involved? Lots of money. Okay. Right? She's in it for the money? I guess so. We'll see. Or he obviously could be a really, really rich woman, and he's in it for the money. I'm not sure. It might have just been true love. Right? You guys are what? 15, 16, 17, 18? Yeah, so start scouting out around 60 years old right now. I'm just kidding. Okay, and the relationship between them is called a correlation. This, we would say, has a positive correlation because as the x values get bigger, the y values get bigger as well. So three possible correlations. We have positive correlation, so your x values get bigger, your dependent variable, which is your x variable, and your independent variable, or sorry, your independent is your x, your dependent is your y. They both increase together. Negative is decreasing, and then sometimes there's no trend whatsoever. Okay? So we look at the diagram in the first one. How much money you're making based on your years of experience. Life would be, your work life would kind of be depressing if that was negative, right? I start off teaching, they pay me tons of money. Each year they're like, you're getting better, we're going to pay you less. I'm like, wait a minute. That's how it should work? Get a lot of money right at the beginning? Yes, just 1 second. As far as a teacher's salary for me, when I started teaching, yes, they did pay me the least amount of money they could, right? And then for a teacher, for your first 10 years that you teach, you automatically get a raise. So every year I got a raise for 10 years. Do you know what happens after 10 years? It's like you die. Look at that. Flat line. They just don't increase my salary. Well, there's negotiations, so you get like cost of living. It's like a little 0.5%, 0.25%. But basically, I'm getting the same amount now that I'm old. Maybe they think I can't improve anymore, can't learn new tricks or something. But I got a raise, so my years of experience gave me a raise for the first 10 years, and then after that for teaching, it flattens out. I guess because of the cost of living, it goes up a little bit slow. Let's look at this next one. Okay? Temperature and elevation. This has a negative correlation. The higher you go up, the colder the temperatures. And what do we have as our data in our last one? We've got, boy, day of the year. And what does it say on the other side? Can you read it? Your draft number for entering the Army, maybe. Has nothing related whatsoever to when you were born or what day of the year you get it. So it's all over the place, no relationship. Okay? So what are other things that would have like no relationship whatsoever? Your birthday and your weight. That's right? There should be no relationship between that whatsoever. It's like, oh, March 15th, way overweight. I'm sorry if anybody's birthday. Yeah. Oh, shoot. Okay. All right. Well, I was like, what are the chances that I can actually pick someone's birthday? But I did. Better keep going with the notes before I get into more trouble. So for each relation, I want you to think the distance from school and the amount of time it takes to walk here. Draw a little scatter plot and say, is that going to be positive, negative, or neither? All right, what do you think? First one, positive, negative, neither? Positive, right? This dot doesn't really make sense unless you could like teleport. Oh, I'm really far from school. Boom, just get there in a second. Number of students in this room and the room number. 0. Could be all over the place. Amount of gas in the tank of a car and the distance traveled. Negative. Farther you go, gas will go down. Number of years teaching and salary, right? And here I've got those dots leveling out in the end. So sad, so disappointing. Ooh, attendance and your mark earned in a course. No, 0? Hopefully it's positive. But notice that it might be all over the place, right? I've had students that don't come very often, but do fine, right? Other times I've had a student every single day, they're there. Well, technically they're there. I'm not sure if they're there because their mind is somewhere else during class, but then it doesn't necessarily have a good mark, okay? But probably if you compared an individual student, you know, if they could take the same course, come every day, and then you could go back in time and say, okay, now you're going to take the course, but you have to miss every other day, they would probably do worse than if they came every day compared to themselves. Unfortunately, we can't really do that study yet. Okay, so how to draw a scatter plot. You're going to draw your set of axes. You're going to write a nice title and label both your x-axis and y-axis. You're going to decide on appropriate scale for each of your axes. We've got a title that's specific, and then plot each pair of coordinates. Whatever's in your first column is always your independent variable or your x. Whatever's in your second is your dependent or your y. When we draw a scatter plot, it tells us whether it's positive or negative correlation, but we also have a strength of a correlation. So we would say if the dots are really, really close, that would be a strong positive correlation. If they're still increasing but more spread out, we would call that weak, and something in the middle would be moderate. Same thing with negative. You could have strong negative correlation, a moderate negative correlation, or a weak negative correlation. And it could be that you have a correlation that is not linear. And this might come up for some of you when you decide to do your IA. Maybe you're looking for a relationship between two things and trying to model it with the equation. Some equations model nicely with straight lines. Other equations don't. Okay? So, yeah. So, for example, you might have dots like this. This looks more like a logarithmic graph. Or dots like this. This looks like an exponential graph. So we've got this data here. We're going to put this onto the chart. Okay. Rainfall from 2004 to 2012. When I draw it here, notice this little squiggle that I put in my graph? That's so you don't have to go 1, 2, 3, 4, 5 and have your graph go 2,000 things with nothing and then start 2001, 2002, 2003. Okay, so I made a break in my graph here. And then whatever scale, I'm going up by ones, but I decided to go up 2 spots. I have to keep that scale the same. Underneath those, I need to label what that stood for. Same thing for my rainfall. Since all the rainfall was between 60 and 100, I did a break in my graph there too. There are the dots. And looks like a fairly strong negative correlation. Now, what you do with the statistics, right, with a strong negative correlation, you could say, it looks like it's decreasing. Is this realistic? Does that mean it's no longer, by 2020, it looks like it's not going to rain anymore? Yep, guaranteed. It's going to be dry, desert from that on. Or is this just a trend in that time period, but maybe doesn't allow us to go beyond there? It's never going to rain again. That's most likely what's going to happen. So when we look at that trend, what we can do is we can draw a line of best fit. Now, most of the section that we're going to be looking at is going to be looking at straight lines. But sometimes there can be a line of best fit that's a parabola. Or sometimes a line of best fit is, exponential. Right? You throw a basketball in the air and watch its path, it's not going to be a line. That would be crazy. Throw a basketball, it just keeps going up forever. Got to get a new basketball. Okay, throw another one. It would be really crazy. It'd totally change the game if there was like no gravity anymore and you threw something up and it just kept going up. Right? And then a person jumps to try to catch the ball and you lose them too. Okay? So if you threw a basketball up in the air, its line of best fit would follow a parabola. Okay, here's a couple of examples. Start practicing now. Your typing speed or texting speed, weeks of practice in words per minute, goes up. Do you guys remember the phones where you had to do for texting, like if you wanted to do a C, you had to hit the A button 3 times? Oh. And there was people that were so, they actually had competitions who was the fastest at that kind of thing, right? Now, you put the letter C and it comes up. Did you want to spell chameleon? Oh yes, that's always what I spell when I put C first. And you click it right away. Of course. And it remembers things that you've typed in the past, right? So like people that you always text when you write their name, even though they're not in the dictionary, they're in your dictionary. Weight versus exercise, right? Oh, so bad, right? Here we go. So bad. I'm so bad. Okay. Number of kilometers run per week. And your weight, you start running more, your weight goes down. Unless you're born on March 15th. So researchers can use lines of best fit to make estimations, to make predictions about data. How do we draw a line of best fit if we were doing it by eye? Well, you could take all of your data and find the mean point. And the mean point, or the average point, is going to be what are the average of your x values, what are the average of your y values, and that point is going to for sure be on your line of best fit. That point's going to be on your line of best fit whether you draw it by eye or later on when we do calculations, that point is on there as well. But when you're drawing it by eye, once you have that point, you're trying to draw a line so that the rest of the points are as close to it as possible. So you have about the same amount above and the same amount below. And your line should start somewhere on the y-axis. Not exactly at 0, 0 necessarily, but from your y-axis. So here's our data, right? We've got the total fat and the total calories in each of those meals. Ooh, the big and tasty. You don't have this one? Did it not? Some are, oh, okay.